So that is the uses for the sequence. So let us say we have the sequences are defined in our database, and we want to use in the ETL programming. Then we can get the details here. We can get the metadata details for this particular sequence, and we can use in the ETL mappings. User defined types. So user defined types, this is also this is nothing but one kind of objects. Okay, maybe record types, objects, let us say we have defined in the projects. So those kind of objects also you can use in the warehouse builder. So here you see different types of object types. We have VRS, we have nested tables, we have, right, all these things actually we can use in the ETL process in the Oracle Warehouse Builder. And next one is queues. Queue is actually the queues generally in Oracle we will use for encoding the messages and then decoding them. For example, let us say in the source system we have the source data is, let us say it is keep on changing based on particular transactions. Okay, so what we can do is, using the queues, what we can do is we can define a queue with data types, and when any update or a transaction is happening, at the time we can queue the message. So what is the advantage with this one is, so when we are queuing the message means so something has changed in the source system. So for this particular IDs for a particular table in the source system, so we this something got changed, that is the giving indication. So when we are doing the ETL process, for example, in the Oracle Warehouse Builder we have discussed like we have a Oracle apps system where we will get all the sales information after completing the transactions. So what they will let us say what they can do is when any particular record gets updated in the source system, they will queue the message, push the message into the queue, giving the indication for the downstream. So let us say for our project, saying that this particular record got changed or newly created in our source system. Okay, so queue, what it will do is it will hold the message, whatever the data type we are giving, and after that when we are dequeuing, we can go to the enqueued message. Based on that we can dequeue the particular records. Okay, in the sense, see for example, let us say in the queue, let us say for a particular table 1 record number let us say 1 got updated and it was enqueued into the queue. So our dequeue process it identified that the record 1 came into the queue, so it dequeued, and for this particular message there is particular value 1, we can go to the table T1 and we can pull the record. So here the mechanism here is just to identify the changed objects or changed rows. This is very important for the data warehouses where you want to load the incremental data instead of loading complete data every day. What we can it is a general practice that only the incremental data we will take and we will process. So in that cases it will these queues are very important. they will play a good role. But the only the thing is that in the beginning you have to define the queues and you have to configure on particular tables, columns. These are all the details, like for this table I want to have a column. These are all the messages, and under the messages I will have column 1, column 2. All this information we will define in the queues, and we will create them in the database, and we will enable them. Okay, so when any change is happening, automatically the message will be entered into the queue. So the queues, when they are dequeued, we can get the records into our systems. So these records later will be processed through the ETL process, and then finally will be loading into the reporting layer. That is queues. So dimensions and queues, these are also good things. I mean, for a particular reporting systems, dimensions and queues, they will play good role in the sense, let us say I have a star schema. In a data warehouse I have a star schema. Star schema is nothing but we have the dimensions where I will maintain a different kind of master data. Okay, so here for each record, let us say I have a customer information. Okay, so for each for the customer, let us say I have some customer ID, and for this customer I have different details: the customer name, first name, last name, where he is living. Okay, when this particular customer was introduced to this particular company. Okay, like that n number of details will be there in the customer. So customer is one kind of dimension for me. This is one category of basic information for a particular project. Similarly, let us say I have products. Okay, I have different product for my company. Let us say I have different products. Maybe this company may be manufacturing TVs, electronic TVs, fridge, refrigerators, okay, or some other mobiles. All these different kind of electronic items it is producing. Okay, so these are all the different kind of products. Under the product, let us say I will have different kind of business I am doing. So product is one category of information. That is one kind of dimension. Also time dimension. Time dimension is a very common thing, in the sense a particular company is producing some products, and it is selling to different customers, but it has to sell in a particular time, right? Maybe it may be selling today or tomorrow. All this information we should have. So time information is one kind of category for my project, where I want to do the analysis. And under the time, again, let us say I have a lot of options. Okay, like which day, month wise, quarterly wise, yearly wise. Okay, like that we will have a different options under the time. So these are all kind of master data. These master data means this data will not continuously change. Okay, master data is this is the basic category of information for your business. Different categories I have here. So all this comes under dimensions. Okay, and I have the complete transactional information. Like let us say I have the sales information. Okay, so under the sales information, when we are preparing a star schema, let us say I have a fact table. The fact table, along with the dimensional keys, like along with the basic master data information, I will have the real fact tables, like how much quantity I have sold, how much revenue for this particular product, okay, and how much discount we are giving. All this information we will have in the fact tables. So fact table, it will have the real facts along with the dimensional or business related information. So in generally, what we will do in a star schema is what we do is in a star schema, star notation, in the sense I have the fact table where I am maintaining all the fact details, okay, and I have the dimension tables. Dimension tables like time information I have, okay, I have customer information, okay, I have product information, let us say I have market information. Market means like in which place this particular product was sold, right? So let us say particular company XYZ, is producing, let us say it is selling TVs, okay, it has sold one TV, okay, TV, the product, TV product is TV, but under the TV also there are n number of categories, and it sold to the customer C. How many TVs it sold to the customer TV on 4th March, on 4th March 2016, where this particular TV was sold, let us say in Hyderabad, okay. How many TVs they purchased? One TV they purchased, and what is the cost? 30K, let us say. And how much discount actually the company has given to the customer? Let us say 5,000. How much brokerage fee it has given to the showroom people? Okay, let us say they have given some 2,000 brokerage, or okay. So this is all information I have. So again here customer means just I have given the customer CC I have given. Here see, I do not have much information about this customer information, okay. So under the customer again I will have customer name, his address, where he is sitting, what is the billing date, what is the delivery date, let us say, and what is the delivery address, what is the communication address. All these things, let us say, we have in this particular row, because these are all the details when we have collected when this particular product was sold, right? So every time, let us say, likewise here you see I have given the date here, okay, I have given Hyderabad here, okay, and later let us say I want to identify for March 2016, let us say I want to identify how many TVs got sold. At that time here March is there, here the 4th is date 4th is there, so but I want to identify only some March related products, right? Then it is a bit difficult for me. We can do it, but it is also a bit difficult. And also here the customer information, lot of common for the same customer. Let us say next day he came and let us say he brought one fridge, refrigerator or AC with model XYZ. Same customer, but it is on 5th, okay, again Hyderabad, some cost, all these details. Here customer is same, okay, but under the customer again I have to put all the details, customer name, okay, when he was introduced to the company, customer email ID, customer contact number, all the details. So all the details, let us say I am entering again here, address, okay. So when I am coming to this fact table, if you see the second row, again all these things will come here, the same items will come here, these details also will come here. And also for analysis purpose on March, for the March month, again it is a problem, I have to do some calculation, okay. These are all the difficulties when we are maintaining the complete transaction for a particular business. So what generally we do is we will do the we will prepare a star schema where we will segregate the information into dimensions and fact, and in the fact tables we will maintain only the dimensional keys and the fact measurable values. Here if you see, this is all redundant data. Every time I'm putting the data, every day lot of customers, let us say maybe same customer, lot of transactions, same redundant information I keep on adding, size is growing, and when I want to do the reporting and all, it is also getting difficult. So all these problems are coming. So we are doing a normalization and we are preparing a star schema. So what I will do is I will create a dimension called customer. Under that I will have the CC for under the customer. For CC is let us say I am giving his ID is 1, and under this one I have all his details, his mobile number I have, his address I have, okay, again what is his email ID I have, all the required details for this particular customer. Similarly, let us say I have created one product information, okay, product, again under the TVs what are the sub products, what are the sub product, like that different related to this particular TV I am maintaining. Similarly, market, okay, for the market also, for each location, for Hyderabad what is the state, what is the state, which country, which geography, like Asia or Pacific or America, like this, all this kind of information I can maintain. Similarly, we have time information, very important thing, time ID. For each ID, for every day, let us say I have one entry in my table. For each day, again I have the quarterly information, I have the month, I have a week information, I have month information, quarter information, and again I have a year information, all the information I have. So when this particular record is nothing but the fact information, right? So when I'm putting my fact information, what I will do is here I no need to, what I will do is I will not put all the actual values here, except the facts. All other things I will put with the dimensions. In the sense, see here, TV. For the TV, let us say I got one ID in my dimension. So here I will put TV. For TV it is ID 1. For customer, okay, let us say this is ID 1. I no need to put address, mobile, all these details here. I am removing them. But later if I want to identify the details for this particular customer, I can go to customer and I can get the details. Okay, and for fourth day, let us say I have a number, I have generated one number in the time, let us say for 999 is, let us say 4th of March. And similarly for Hyderabad, the location is, let us say 1, location ID is 1, and all other fact details will remain same. 30,000 is the cost and the discount is 5,000, brokerage fees 2,000, all these details same. So the advantage here is, what we are doing here is we are doing the normalization here, okay, and the advantage is we are removing the redundant data, and also we are maintaining only the dimensional case here. So the advantage with this dimensional case is, let us say if I want to generate a report for March 2016, based on this key I can go to the time dimension and I can see what are all the dates, what are all the IDs belongs to month 2016, and I can push the details here, right? Then it is easy. And for example for 2016 I want to find out the sales, then based on year I can do the aggregation and I can identify. So if you see here, fact is in the center, surrounded by all the dimensions, customer dimension, then I have dimension market, then I have dimension time, then I have dimension product I have. See, fact is in the center, and this fact is referencing to customer ID. Again, this fact is referencing to market dimension. Fact is again referencing to product dimension. This fact is again referencing to time dimension. So if you see this, it represents like a star. That's how this name got star schema. And if you see in the dimensions, we can say that different hierarchies or levels. See, day, let us say in this particular time, day is the lowest level. Okay, level 1. Level 2 is week. Level 3 is month. Level 4 is quarter and year. These are all the different levels I can maintain in my time. Similarly for market, lowest one location, under that state, country, and which continent it belongs to. Similarly for product, different hierarchies and different levels we can maintain. So these are all comes under dimensions and cubes, right? So what we can do is we can define the dimensions and the cubes in the database itself, and we can load them so that we can use it for the reporting. The advantage if you are defining dimensions and cubes is directly you can take the definitions to the reporting system, and there you can use the hierarchies, levels, all these dimensions. Otherwise you can create the direct fact and dimension tables like simple tables, and then you can do the hierarchies and levels in the reporting. These are the two different approaches. Okay, so as per your requirement, you can have dimensions or cubes in your projects. Data auditors generally we will not use. And the transformations, this is the important one, transformations. For example, okay, 1 second. Again, transformations. In OWB, transformation means in database terms it is nothing but a function or procedure or table function or package. So why we are putting these kind of objects? These are all programs, right? Functions, procedures. We can do everything in a data warehouse or in a ETL. Every time we may not be able to do everything with the select queries, right? Even for the select queries, again at the end we may have to do insert or update kind of operations. All these things can be handled in the procedures or functions or packages. So a series of steps or a series of actions that we want to perform in a particular ETL operation can be handled by functions or procedures or packages. So let us say I want to identify a particular, what we can see, we have the employees and we have the sales information. Let us say here let us say I want to identify how much discount, how much brokerage we have given, how much discount we have given, what is the total cost, and finally what is the cost to the company or revenue to the company or profit to the company. So here let us say while calculating the revenue, let us say I have different calculation. So what is the actual cost, I mean what is the actual revenue we got from the customer, and what are all the different operational costs included in that one. This is different operational cost. Let us say I have a particular formula, xyz whole square plus some ABC divided by some factor, something like that. Let us say we have some complex calculation. At that time what I will do is, So it may not be able, we may not be able to put everything into a particular select query. So what I will do is I will prepare a procedure or function. So it will give the complete result. It will give a series of, we can define all the series of steps or calculations, and finally we can give the result. So that is how functions and procedures are used. So the basic difference between a function and a procedure is function will always returns one value, but procedure it can have n number of outputs, but again you have to read them into some variables so that you can use them in later. But functions you can directly include in your select queries also. That is the advantage. So again, what is the packages? Package is nothing but bundling similar kind of business into one product. For example, let us say I want to have a revenue calculation. Under that I have a lot of calculations. Okay, so for example, for India I have a different calculation. Let us say for America, let us say I have a different calculation for the sales product. Okay, but and in different countries, let us say we have different calculations, and these are all related to, let us say, sales, but different programs or different calculations, let us say I am doing. Okay, so what I'm doing is, what I'm going to do is I am grouping all these similar kind of programs into one bundle, so that it will be modularity will be coming into picture, and it will be easy for me to understand or to look into the details. So here modulars, here the Scott module and this module is different. Here package means it's a modularity where we can have a similar kind of business information or similar kind of business programs. So package will contain procedures, functions. It can have n number, or sometimes 1 or 2, or sometimes may not have, or it can have n number of functions, or sometimes 1 or 2 functions. That depends on your requirement, so that it is easy for your maintenance purpose. So you can write down, let us say for the sales related information, for geography, and let us say there are some 10 procedures are coming, 10 different calculations are coming. You can define 10 procedures on database, but every time when you are going to verify the details, it is very difficult because they are all scattered, right? So instead of that, what I will do is I will define all of them under the package, and I can verify later for easy. So then I know that, okay, revenue related calculations, let us say I have in this particular package. So then it is easy to understand and easy to communicate also. So procedures, functions, let us say we have defined something in the database as per your project. So those things also actually we can use under transformations section. So we can take the same definition from the database and we can use in our ETL process, or you can create them here and you can use them here. But before that we have to deploy into the database. So all these objects here, we have two approaches. Let us say all these objects are already available in the database, and I am taking the metadata information and I am using them in my ETL mappings or programs and loading. That is one kind of approach. Another approach is, generally we will do in the beginning, is we can create the objects here itself. Let us say I have tables. I can create a new table here. Okay, I can define for this table what are all the columns, what are all the data types, what are all the keys I have. All these things I can define here. But this we are doing in the Oracle warehouse builder, not on the database. So when the program is running, it will check in the database, not in the Oracle warehouse builder, because here we are maintaining only the metadata. So if you are defining anything here and if you want to use in the programs, then what we have to do is we have to deploy them first into the database. That means you have to create them into the database using OWB, and then you have to start using them in the programs. That is how it works. So the final component is mappings. This is the most important one in warehouse builder, and where actually we will spend most of the times. Like, these are all the different objects we have. Let us say we have structural information we have for all these objects, and then we will define our ETL programming using the mappings. So mappings are nothing but a graphical representation of your business. Okay, so what we will do is we will have the objects, tables, sequences, packages, queues, all these things we have in this particular project. We are using them, and we are creating a mapping with your business, and finally where you want to load this information. All these things we will do using the mappings. So mappings, when we are creating, it will define the business logic, and when you are deploying and executing, actually final it will load the data into the target tables. So the main thing is that finally we have to load the data so that it can be used for other purpose. But before loading the data, we have to do lot of transformations, like business definitions we have to implement, or we have to modify the data, or we have to implement, we have to clean the data sometimes. Okay, we have to modify the data with the raw data we are taking, and as per the business we are transforming into some other form, and then finally we are putting into the reporting layer. That is what everything happens in ETL: extraction, transformation, and loading into the targets. So extraction is getting the data from your source system. Okay, that is the first step. And do all your business transformations or business definitions, define them, program them, create the mappings here, and finally load the data as per the requirement. That is what is all happening. So we will see how these objects we can use, and how to prepare the mappings, and how to deploy all those things in the coming slides.